1 minute further. If you finish it, you can upload your answer for reference. So anyone want to try to share your idea? If yes, yeah, we have a group full. So Yixiang, you want to share your idea with us? Okay, right? So you just come to the front desk, this one. You can use my mouse there for sure. And right now, 2 minutes for you, or maybe less than 2. Speak louder.
Oh. Give it a try. Okay, so about the first question, it asks us as why it is necessary to use the spatial initial sequence numbers in the how to pronounce it SYNAC. Okay, and then I guess that the answer is that it uses it to ensure that the attacker cannot easily record the sequence number because the sequence number is generated from a very complicated function related to the source, the 4 tuple information involved in the segment. Okay, this is for the question A. And for the question B, I think that the answer is no. And the reason is that, just like what I mentioned, the cookies are generated using a very complicated function. And in the article, it calls it a hash function. And so it therefore compares the sequence number it generated after it receiving the segment from the client. It will generate another new sequence number to compare with the ACK. And if the number it generates now plus 1 equals to the ACK number it receives from the client, it validates that the client is a legitimate one, so it will open a connection. Through this mechanism, the attacker cannot create the half-open connections because it cannot be verified as a legitimate client. Yeah, it doesn't have the same 4 tuple information from the previous clients. Yeah. Okay, and then for question C, I think a little bit confused, but I guess the question is still no. Okay, yeah.
Okay, that's it. Just for your reference and for Huei-Wen, you need to indicate you are the presenter for the current problem. And of course, same. This problem allows you to finish the answer before 4 p.m. today. So we have a full problem for understand checking because we already have 2 videos for checking before the weekend. Maybe I think before the weekend, so you can continue until 4 p.m. today. And forgive me because I still need to collect your answer, so I cannot explain how we have the solutions. So I just already have the uploading your answer to Padlet further. So this is the discussion for the first class. And let me go to this one. So even you think you need to pay your attention to the video, but I think I didn't know in the beginning of the semester we may have some free classroom video for you for viewing because sometimes we need to have the time control. And of course, next week we have the quiz, right? And this week I tried to have the solution to this chapter. And of course, you need to check some selected problems there. And of course, you can have the exercise before I release the solutions to you. And next one, we will check congestion control. Well, congestion control, like the current figure, this one, yes, similar to this one, we have the congestion in the internet. Therefore, we need to have some possible control. But right now, we just already have the general principles of congestion control. It is not the dedicated version of TCP. After this, we will have the dedicated TCP congestion control. Well, so currently we don't have TCP congestion control directly. And we just already have the general principles of congestion control. So I think you, based on the current figure, you will know, or maybe you have some idea about congestion. That says too many sources sending too much data or too fast so that the receiver cannot handle that properly. All right. And if we have the phenomenon, then how you will find we have the problem. Here we have the possible way to manifest. Here we have manifestations, long delays. Well, talking about highway, if we have congestion, you need to wait a long time, right? So long delay. And packet losses. You try many times, but you cannot go there. So we have another one because of a long delay, you may have losses. Or maybe, yes, we have the buffer, but the buffer cannot, for example, try to transmit the packet to the link because of the congestion. So you cannot transmit properly. Therefore, the buffer keep there and overflow the data. So you will find packet losses. Here you can have packet losses at the buffer, intermediate buffer, or something else. And also you may have the other possible packet losses. But if we talk about congestion, it should be packet losses at routers because router cannot process that properly. Why? Here we have this one. Too many sources and too much data. So we cannot allow the router to handle properly. And this one, the same as flow control. Flow control actually try to let sender know the possible rate you need to send. But right now, okay, even I have that control. Still, we have too many sources to send data to the network. So the router still cannot handle the scenario possibly. So this one different from the flow control. Of course, it's really important, so we set it to top 10 problem. Well, later we'll just show you some scenario to let you feel. We already know we have too many sources. So right now we try to increase from the simple one. Okay, right now we have two flows only. All right, so we will have the original data and we expect the data like the original data. And this time we have the assumption. One router, infinite buffer, so no losses. All right, we have input-output link and capacity is R, and two flows here. No retransmission needed. So we have the perfect assumption. And here, we want to ask you to check what happens as the rate increase to R over 2. Actually, we try to have the user full rate. Actually, later we will let you know if we have a TCP connection. Connection 1 and connection 2 will share the bandwidth. So that's why we ask you share bandwidth R over 2. That says we approach the congestion level. So we have this for you. We will share the bandwidth later. We will explain why share. So we have the current rate connection. We have in to R over 2. Once we reach this one, something wrong with so currently it seems to be okay. So